So I wanted to cover today ZFS and snapshots. And I've set up a little demo here. I remember there's a lot of questions some people had, and I wanted some clarifications so people have a better understanding of how snapshots work in ZFS. Now, I like FreeNAS, which is based on FreeBSD, which also uses ZFS as the file system underneath to manage all the storage. And I'm a huge fan of ZFS. You've maybe seen my video on ZFS torture testing, and it's really a resilient file system. I mean, no file system is absolutely bulletproof, but I tell you what, they've come a long way with this. And a lot of that has to do with the way it's a journaled file system and the way that journaling works on this file system. So a journal file system that does copy on write, I'm not going to get real deeply technical, but in short, you're keeping almost like a ledger of all changes to the hard drive. Those ledgers have a series of checksums before the next piece of data is written. It also very intelligently, and this is one of the reasons they ask, ZFS is a little bit memory hungry, which creates the concern that people have about ACC memory, is it uses a lot of memory to try to manage all the writes in a very efficient way. Because it's not caching in the normal sense. It's pulling that ledger, putting it into memory to quickly and intelligently distribute the data across the RAID arrays that you have in here, and it also minimizes the read and writes. But the other advantage of a journal file system is the snapshotting feature. Now, what you're doing when you're snapshotting is you're creating a snapshot of that journal and saying, don't delete these files. But the snapshot itself doesn't take up space, which is also really cool because it only is a differential of space between files added or data added, changes to the drive. And it's syncing on the delta of the change. So if you have a very large file and that file only changes a little bit, it doesn't have to account for the entire file and keep 2 copies of the file. It is the differential change that that file had. This also makes it really interesting. That's one of the reasons I put a VM on here, because VMs are one large file. And so let me show you the data we have on here so we can get into the hands-on, which is how I really learn, and I think a lot of other people do, because I could probably sit and explain this for a long time and not get it, but we're actually going to show you ZFS in action here. So here's my box. I copied some files. Let me move that one out of the way. This is the share. Mount 4 drives RAID, my creatively named 4 drives RAID, and VBox test. Because there's a VBox on there, I called it VBox test, but there's also some data on here. This is your standard data set. So here's the sum data, which I threw a video in here. And here's the test, which is a Windows 7, a clone of my Windows 7 machine, VirtualBox machine, in a VMDK file. So the file itself, let's see, is we got 30 gigs file here. And there's some data. This is 92 megabytes. So there's some data in here, about 30 gigs roughly. Now let's go to look how the ZFS reports this. So here's the FreeNAS box, and we're going to go ahead and jump over and refresh this again. So because ZFS uses compression, here's my VBox test on the creatively named 4 drives RAID. It's using compression. So the actual used size is only 17.3 gigs because by default it has LZ4 compression turned on, which really doesn't have much of a loss. But because of the way the VMDKs are, it actually is able to go, I can store that more efficiently. So I only have an actual stored usage of 17.3 gigs in this drive. And currently there's no snapshots of this. So we're going to go ahead and create one by going down here and hit create snapshot. Now you can turn snapshots as an automated task to snapshot in at increments, and we'll show that in a minute. For now, we're just going to go ahead and create a manual snapshot. All right, and we're going to do snapshots. We're going to filter it because I have a lot of other snapshots going. This is one of my machines that we're using in production. So here we go. It's using 0. The referrer is 17.3 gigs, and so there's the use. So clone snapshot, delete snapshot, roll back snapshot. So we'll just do something simple here. Let's dump a couple more files here. So we'll paste this over. There, just dropped a bunch of random thumbnails in here just so it has something in there. So now we've added to this. Now if we go here and refresh again, the only difference it took up. Now, it's only 81 kilobytes of difference is what it says. And let's see how big is this. This was only 4 megabytes, but because of compression again, it's only showing the difference on there. Now, if we go here, we see the thumbs are in there, and we're going to go back and we're just going to clone this, or we're going to roll back this time. Not clone it, but roll back it. So we're going to roll back snapshot. Are you sure? All right. And let's go refresh. And it's gone. Now that snapshot is destroyed that because we rolled it back to the previous state. There's nowhere you can see those files. We've now destroyed them. The same thing here. Let's go ahead and delete these two things. We're just going to, hold on, shift delete, I believe. Yep. We're going to delete these things off the hard drive. So I'm going to go back over here, volumes. It hasn't refreshed just yet. Go back over here. It's still showing usage on there because we have a snapshot. So go back over here. Now it has 17.3 gigs that it's holding. And now that's why you're seeing this in here. So we have this, and then we can go and dump some more files. Let me find something a little bit bigger. All right, we copied over one of our Vlog Thursdays, which is about 4 gigs. So let's go ahead and go look at our storage again. And as you can see here, the VBox test now has 21 gigs because even though we've deleted that, it's being held by the snapshot. So we go over here and we'll filter for that particular snapshot. And it's still holding at 17.3 gigs. I think it does refresh and it'll show that there's a little bit more. But now you can see the volume actually has to keep reserved that much data. So it's showing 21 gigs to have both of them in there. So here this is, and this is how it was looking. And if we just go to the snapshots, and we're going to jump over here and filter them again. And let's just go ahead and roll back that snapshot. We hit OK. We rolled it back. Refresh. Instantly. Now, this is one of the advantages. It's not like I have some super incredibly fast machine. I mean, they are NAS drives. It's a reasonably fast machine. But the beauty of the way ZFS works is because you're just looking at the ZFS journal, you're just manipulating it very quickly. So it doesn't have a bunch of files to copy. The files aren't being moved. You're only changing essentially the journal / pointers in a file system. You're saying, okay, put the journal back to where it was so everything points exactly how it did when you took the snapshot. This means that quickly I can roll back data. I could have created another snapshot and roll back and forth between them. This is one of the beauties of ZFS is you're snapshotting a journal, not the actual files in the way that a lot of people think of it, like you're making a backup copy of all the files. This allows the snapshots to be non-disruptive and almost instantaneous, even with very, very, very large data sets. It takes very little time. So we've actually created clones of like 3-4 terabytes at a time, and they just pause for a second, done. So as long as the machine's under generally not high load on a hard drive and it's not completely at wait states, then it snapshots data really, really fast, which is fascinating to me, like how well this works. So if you go, oh no, I need to roll something back, you can simply run it and just roll it right back, and it's very, very quick. Now, I have here, and I'll show you that the replication tasks, the periodic snapshots, I have a couple of them with mine. I snapshot my production VMs once a day, and I snapshot my syncing data once a day. That's the only real things I have running on here. And it works really well, and it creates, when you go to the snapshots, that's why there's so many of them in here, auto, and you can see the different ones, and you can roll back or clone to the last one on there. Now, when you do a clone, so let's go back to our snapshots and filter for test. Cloning, it's a little bit different. So if we go to clone, it actually creates in the storage over here, here's the clone. Now, when it clones it, that is a great way to do this. And we just had to do this for a client the other day. The clone, they had changed something but we had a snapshot of their entire file system, but one person had somehow goofed some things up, and we had it set to snapshot a couple times a day. And what they'd actually done was delete things at they created some data at the beginning of the day that they deleted before the end of the day, which meant it didn't have a way to back it up. So we just ran and found the clones, but we clone a couple times a day for this client with their system, and they have several terabytes worth of things. But lots of people made file changes. So that's where clones come in. And with the clones, it's a snapshot in time of that one. So it's kind of like a fork off the file system. So what we do is, because we don't want to rechange the entirety of that data set, the clone creates a separate one. Now, I have to go in. I can't see this. Cloning it doesn't give me any visibility in here to that. So I actually have to take the clone and manually make another share for it. So I go to sharing and I create another share on the clone. And this was very handy in the circumstance that we had for the client, because like I said, we didn't want to change the whole data set. We only wanted to find the file that that person had. Therefore, we created a clone. We actually found the person's files. They were absolutely in the snapshot. And then we copied them back over to the main share. And then when you're done, you destroy the snapshot. So we're going to go ahead here to the clone and destroy the data set of the clone. It gives you a nice red warning because you're destroying a data set, and you cannot come back from destroyed data sets. So now that data set's stored, and we're left with only this one. And when it comes to snapshots, filter, this one's still here. Now, let's see how this works in a VM environment. So we're going to go ahead and fire up my Windows 7 virtual machine, which is, there's the VMDK, and it's pointed towards it. So let's go ahead and open that up. Oh, and I let this boot in real time to show you. I'm running my VM across a gigabit network, not a 10 gig, but just a 1 gig network. And you can see that running a VM across there actually works really well. It boots up really fast, no problems here. So here's the hard drive for the system. Here's some stuff on the desktop. And let's go ahead and open up the FreeNAS again. So here's the FreeNAS control. And we're going to go ahead and, I guess we can destroy this snapshot, and we'll create a running snapshot. So I'm just going to get rid of them because we're not using this one anymore. And while the VM is running, so Windows, as you can see, is in the background here actually running, we're going to go ahead and create a snapshot of it. So we go to storage, we go to here, create snapshot, manual snapshot. You know what? We'll even put the word VM running. So I know which one this is. So manually create the snapshot. Now this is a running open file system right now. It's attached, it's running, and Windows is running in the background. This is kind of important because there's also a few concepts here. One thing I will tell you, and I'm not going to demonstrate it here because it causes my computer to hang, but it does work. You can restore a live running VM and roll back while it's attached, but it will absolutely crash whatever operating system, whether it be Linux or Windows. You'll end up with a system not running properly because all of a sudden you change the underlying virtual drive. So we cloned it while running. And let's make some changes. So let's just delete these things off the desktop. And we'll open up. I think there's some stuff I can uninstall. So let's look for something. Yeah, I don't need TeamViewer in here anymore. So remove it. So we're making changes to the system now. And let's go back over to ZFS. Yeah, we don't care. We don't need to fill out that. All right, and we're going to go over here to snapshots. Now, here's what's interesting. We only removed a little bit of things, so there's only been a little bit of change. But this is technically one giant big file in here because it's the VM file itself. So even though that this file is a 29.7 gig file, FreeNAS only has to track the little changes made. This is kind of an interesting thing because normally if you're backing up files or creating snapshots of them, you're thinking of creating a snapshot of file. But because FreeNAS is only looking at the changes made at the file system level, it's not a duplicate. You'd normally have another 29 gig file, or because compressed at 17.3 gigs, you'd end up with that. This is what's interesting about the way this works. It's referred to as, I believe, syncing on the delta changes. So it actually looks at the differential changes of that file. That's what makes ZFS super efficient by doing that, because it's storing it almost like a database and says, I'm only tracking that there was 17 megabytes of changes, which was me removing the team viewer from there. That's the only changes in that. So now let's go ahead and shut this VM down. We removed team viewer. Not in there. We deleted some stuff off the desktop. And we took a snapshot before we did this. So while the VM's not running, I can roll it back while the VM's running. It's going to crash. I did the test. It locks up, and then it causes my computer to go a little bit crazy. So we're going to head to roll back snapshot. Are you sure you want to roll it back? Yep. We're going to undo that change. I'm going to go back and open up Windows 7 again. Now, Windows 7 is going to give me an error when it comes on because it realizes it wasn't shut down properly. Yeah, we're going to go ahead and start Windows normally. I'm not even going to bother doing a file system check on it. And it still boots up reasonably fast. And there's all the icons on the desktop. TeamViewer still installed. And away you go. So it actually lets you take snapshots while the VMs are running. The only downside is it's the same as when you restore it as if you just pulled the plug on it, because you grab the file system as it was at that time. So when you reboot it up, and Linux does the same thing, it goes, hey, this file system was not shut down properly because you grabbed it while it was running. But nonetheless, it works, and I can easily roll back to several versions. So you can create these snapshots of your VMs while they're running and be able to restore it. I mean, granted, you're going to have to deal with the corrupted possibility of file system corruption of when you took the snapshot, but that's generally not a big deal because most modern operating systems, they're somewhat fault tolerant to be able to do with this, and you're creating multiple snapshots generally. So I create one a day and let them keep for a week. And that's how you can, keep nice safe states of not just your files, but things like your VMs. And the fact that it's so efficient, and the reason being because it's only looking at the changes. So even though the VM file is one big contiguous file, it only sees the changes in that file, and that's the only thing it's sacrificing on storage. Now let's talk about how we automate the snapshots so you can be worry-free on there. So if you look at the snapshot tasks, and we'll look at the one right here, for example, on my VBox store for these, I am keeping 1 week, and I say begin at 4 a.m. and AM do once a day. So that means it's going to run here. But you can actually change this. So if I wanted to change the interval to be hourly, 30 minutes, 15 minutes, you could actually have your file system going through and taking even more snapshots. I also like when you do this, in case you can't remember what you changed, it highlights the last one you had. So if I wanted to have hourly snapshots of things, let's say you're running a mission critical system that you want hourly changes that you want to be able to roll back to, you can set this to 1 hour, and you can set it between these hours to do it. So that becomes a very interesting way to do it because it gives you a start and end time. So during business hours, go ahead and run these snapshots because there's not changes happening after business hours. And then how long do you want to keep them? 1 week, 1 day. Now, the important part about this, there's limitations to storage, as in there's only so much storage you have. So you have to do this consciously with making sure you have enough storage to do it, because eventually you could overrun the system and fill it all up because someone makes a lot of changes on a production system. Make sure you plan ahead. Generally, you want the ZFS also to eliminate fragmentation by having plenty of space on the drive. By doing this, ZFS gets more legroom to kind of stretch out and spread the writes across. So always overplan as best possible. I know it gets a little pricey, but if you overplan your capacity, you will have a better time because you can keep more snapshots. ZFS can spread the writes across the drive, and it's a more intelligent way to do it. But that's my introduction and kind of overview to snapshots and how they work. It's not too complicated other than the cloning, because you have to create that, and you have to create the different share if you clone something back. But on the other side of it, if you just have, like I have, these clones here, I can easily just jump backwards in time and go, hey, let me go back to this refer or that, with my VMs, with anything else. And you can set it to once a day, or like with some of our clients, we have a very large array with them running FreeNAS, and we set it up a couple times a day. That kind of saves them for people who do things like create data and don't have it backed up in time, and then they goof things up. So you can just roll back. Hourly is maybe good. It's all decisions you can make, but it actually lets you do that, and you can do this with VMs. Now, this also works for other ZFS devices. I haven't tried it, but as far as I know, it works fine with like the iSCSI interface. You can create block devices and still snapshot them. You can snapshot anything really that you have on here. So if you want to get to the more complicated ones, definitely works. It's also interesting because that's how ZFS and FreeNAS handle the jail system. When you create the templates, it creates a snapshots for those templates. That way they can easily be restored or cloned to create more features. So if you create a jail and you want to duplicate that jail again, you just go ahead and create a snapshot of it, clone it, and now you can duplicate that state of one of the FreeNAS jails. So thanks again for watching. If you like the content here, like and subscribe. If you have more comments, questions, or something I wasn't clear about on ZFS, or if you think this needs a part 2 to do some type of test scenario, let me know. But hopefully this clears up ZFS and snapshots and how they work and why I think they're amazing. Thanks for watching.